In this video, what I want to do is change the radius on a satellite and just see how that affects the angular momentum and compare it to the velocity change. That's if we change r. So we've got our normal Earth, we've got a little satellite here, it's at a distance r, and we change that. Maybe we decrease it by 10% or something like that, or halve it. Now, we've got our formula for v for a satellite in orbit is equal to big G, big M over r, and all that is under a square root sign. That's the velocity for v. So, what is our velocity for angular momentum? Well, for the satellite just going around at this radius, angular momentum is this one, the mass of the satellite times the velocity times the distance it is from the center of rotation, but that's a perpendicular distance because we're not using cross products, which are a vector thing with this. So if we go back to that math skill one little video, if we want to change the radius, let's see, what should we do? Let's double it. So if we double the radius, what's it going to do to the velocity? So under the square root sign for the velocity one, if we now have gm over 2r square root, now we can bring that 2 out, can't we? But to bring a 2 out from under that sign there, so this is the same as the square root of gm all over the square root of r, but now we've taken the 2 out, so that would be a 4. Alright, sorry, that would be a square root of 2. Just doing it around the other way in my head. No, that's a mess. Let's just bring that over. So that would be a square root of 2. Right? Now, that's all equal to v. So, if we've actually taken a square root under there, then how's that going to change the velocity? Go back to that. This is what we're basically saying. V times the square root of 2 times the square root of r is going to be equal to the square root of g and m. But they're constants. So the only way we can multiply by the square root of 2 is if we divide by the square root of 2. So the velocity needs to be divided by the square root of 2 if we double the radius. Okay, so bigger radius, slower velocity, but we divide it by the square root of 2. So we have doubled the radius. Let's not forget that. Now, what happens to angular momentum if we do that? Well, if we were to think in terms of conservation of angular momentum, we've got L equals mv r dash. For that to stay a constant, right, and if we now double the radius, we're saying mv 2r needs to equal a constant. Now the only way we can do that, we can't change the mass of the satellite, but we can divide the velocity by 2 and we'll still have it work. So for conservation of angular momentum to work, we needed to divide the velocity by 2. But to get conservation of angular momentum, if we take the satellite out to twice the radius. But if we take the satellite out to twice the radius, from a velocity point of view, for all that to work, we would need to divide it by the square root of 2. So we can't just get a change in radius for the satellite and get conservation of momentum or angular momentum to do our work for us. Work needs to be done.